Who is that? So you want to build a DIY PowerWall. I'll show you how to do one. Using these as batteries and these as your inverter, you can build a small DIY PowerWall. Let's get going. I have an idea of what it is. Oh yeah, remember these guys? So today's project is going to be pretty simple. It's going to be using 10 of these battery modules in series to make 36 volts and connect them into this 36 volt UPS. We're gonna take this out of this box and house it in the same box as this one, just in an attempt to be creative and to be able to put this in the wall easier, because this is kind of chunky and it doesn't hang in the wall very easily. So the first thing you're gonna have to do is gonna be buy this box here and then screw it to the wall. I don't think I have to show you guys how to screw a box to the wall, so we're just gonna pretend that you guys already did it. Now next thing is going to be to see if 10 of those modules fit here. That could be tricky sometimes. Let's see how we do. All right, so 5 in a row here is going to work. So now I just have to wire them. Well, there are several ways to interconnect all the modules. There are the original ones that go in between here. I didn't get any of those, so I can't show them to you. So the cheapest one is just to use solid wire, solid cable. Of course, you will have to keep in mind what kind of load you're gonna put onto these. In my particular application, I'm not gonna load them up too much, so even this thin cable will be enough, right? That's the cheap way to do it. All you do is you make a bunch of these, and then you install them there. The second least expensive is this, right? The reason why this is kind of expensive is because these are expensive. They're probably $1.50 each, so there's like $3 here. It's quite a bit, right? And then the cable itself, right? This is the cheapest one. This is 8, this is 6. I like using this because this is silicone. This is welding cable. This is RC, you know, high temperature silicone. This is probably what I'm going to end up using because I love working with that because it's super flexible. And so that's why I like doing so. I'm going to make mine like that, but I want to show you that there are different ways of doing this. Alright, now that we got our modules all wired up, it's time to install these guys. These are Longmans. These are the sensors for the BMS, and they have to go, they have a temperature sensor in this board, so it really helps if you're able to install them right here, right on top of the batteries, so that if this module here gets hot, then the sensor picks it up, it sends it to the main unit and says, hey, disconnect, lower the rate at which you're transferring energy in or out of the cells. There's a bunch of things you can schedule to be able to do or to happen in the case of hot modules or for the temperature that goes up a certain amount. So we're going to install those here. I'm going to use double-sided tape to tape those on there. Hopefully the double-sided tape will transfer the heat into the sensor. Let's do that now. All right, before we get going too far right here, I want to check that this unit works before we take it apart and, you know, do all that extra work for nothing, right? All right, so that turned on. I don't know, 75 watt light. Oh yeah. You press that and hopefully it should shut up. I'm powering that using a single hoverboard battery. There we go. And we have light. So this thing works. Now let's take this thing apart. Alright, I freed the guts off of inside of that box of this UPS inverter. Now let's put it in a new home, in a new box. Let's put it over here. So the idea here is simple. It's just to stuff the battery, the UPS, and the charge controller into the same box. That way it's all self-contained into one box, and the only thing that's going in and out are connections. In from the solar panels and out AC, where you can use it to power whatever appliance you want that is within 900 watts that this UPS can provide. Let's do a walkthrough to all the components in this. At the very top here is a charge controller. Solar power comes in here, it goes through this one, it goes into this solar charge controller. Here's the screen for it. I used to have two of them here, but I took one out because we don't need it. And then from there, the power goes out and it goes into the battery through this. This is a shunt for this meter here. And that meter is exactly going to let us know what's coming in and out of the battery. Right now it's discharging, 11 watts is coming out, so that is going through there on the negative. On the positive side, this is a fuse, 40 watt fuse that I put in there, and when that blows, this little light should turn on. Then that goes and connects to the battery on this side. So on this side is the battery, on this side is the solar charge controller, and that connector is for this, which is the UPS. Here's a fan, here's the transformer. You might have to fudge that a little bit to be able to make it fit here. It's a tight fit. This is the biggest part of the UPS. So the power out goes out through here, and then goes out through this, and then it goes in here. This could be a conduit so that you can put it into your wiring, or into a you know, like a strip. Or on this case, what I did was put a little electrical box, and then you just connect there. So the only problem with this transformer base inverters is that they make noise. You can hear that hum and stuff. That's that transformer running there and the switching. On the bottom here then is the battery. There's the 10 modules, right? And each one is 40 amp hours, 3.7 volts. So fully charged, 42 volts. So this one's not fully charged right now, it's 39. Fully discharged is 30 volts, and this thing quits about 30 volts. I just tested that on this unit over here, and it quit around 30 volts. So that's cool. Right now what I'm doing is charging using the charger built in here, and it went from 30 volts to 36 volts, but it's staying there. So maybe it doesn't go all the way to 42 volts. We will see. All right, on the battery here, we have all these 10 modules in series. This is the most negative, and then it crosses to this one, to that one, to this one, to that one, then it crosses up, and then it crosses. So that's 10 modules, right? These here are the long ones for the BMS system. I will run through the setup of this on the next video. For now, this is our DIY PowerWall. So how much does this PowerWall cost? Let's do a rundown on the prices of all the components. First, we have the solar charge controller available for $38.99, the bidirectional meter at $29.99, non-interruptible power supply available for $30. The battery modules are $50 each. There's 10 of them, so it's $500 in total. The 32-inch metal box is $59.22. A fuse holder is $682. The battery management system, the long ones are $14 each, and the main unit is like $200, so it comes down to a total of $342. All of these components come to a grand total of $1,008 US. You can find the links for all these parts on the description of this video. I want to thank you for watching. Stay tuned for future videos all having to do with DIY renewable energy.